Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P16E2 indicates a PGM-FI-ACG LIN communication error in the Honda CR-V model from 2023 onwards. This error typically arises when the Powertrain Control Module, PCM, is unable to receive signals from the alternator through the local interconnect network, LIN. The LIN communication is crucial as it transmits essential data that the PCM needs to operate correctly. If the communication line is compromised, the PCM identifies this as an abnormal condition and stores error code P16E2 for further diagnosis. Commonly, it highlights issues related to the alternator or its associated circuitry. Understanding the implications of this DTC is critical for accurate troubleshooting and corrective actions. The error P16E2 specifically points to a failure in the communication between the Powertrain Control Module, PCM, and the alternator through the local interconnect network, LIN. The PCM is responsible for managing engine functions by receiving signals from various components, including the alternator. The alternator ensures that the vehicle's battery is sufficiently charged and also communicates its status to the PCM via the LIN. This error might occur if the wiring harness connected to the alternator has loose terminals or if the LIN communication line is interrupted. Locating the affected components is vital, primarily focusing on the alternator's +B terminal, the PCM, and any connectors associated with the LIN. Any malfunction in these parts can disrupt communication, ultimately triggering DTC P16E2. Several factors may contribute to the DTC P16E2 error code. One of the leading causes often identified is a loose terminal connection on the alternator, particularly at the +B terminal. If the connection is not secure, the PCM may fail to receive necessary signals from the alternator. Further, any interruptions in the wiring within the local interconnect network, LIN, can also trigger this error. This could occur due to wear, physical damage, or improper installation of the wiring. Lastly, a malfunctioning Powertrain Control Module, PCM, might mistakenly signal a communication error due to internal faults. Identifying and addressing these potential causes is critical to resolving the DTC P16E2 effectively. The symptoms accompanying DTC P16E2 can manifest in several ways. One primary indication is the illumination of the warning light on the vehicle's dashboard, signaling a communication error. Drivers may also experience various vehicle performance issues, which may include reduced power during acceleration or erratic engine behavior caused by the PCM not receiving accurate engine data. Furthermore, if the alternator is unable to communicate effectively with the PCM, it may lead to a malfunction in the charging system, resulting in a discharged battery or dimming headlights. All these symptoms warrant thorough diagnostics to pinpoint the root cause of the problem effectively. For the first step in troubleshooting DTC P16E2, ensure the vehicle is in the on mode and wait a minimum of 10 seconds. This initial step is crucial as it allows the vehicle's systems, including the Powertrain Control Module, to boot up and establish communication with all associated components. This waiting period ensures that any transient faults or temporary communication issues are eliminated before deeper diagnostics begin. This systematic approach is vital to accurately determine if the P16E2 error is persistent and if it requires further inspection of the related circuits and components. In the second troubleshooting step, check if the DTC U1B0 is indicated along with P16E2. DTC U1B0 relates to a communication error and may suggest a broader issue affecting the vehicle's communication networks. If U1B0 is present, further inspections will need to be directed toward general communication faults. If U1B0 is absent, it narrows down the issue specifically to LIN communication concerning the alternator and the PCM. Understanding whether U1B0 is present or not dictates the next specific inspection steps, making this diagnosis critical in guiding the technician toward resolving P16E2 accurately. The next step involves inspecting the alternator's +B terminal for any loose connections or signs of damage. The +B terminal is essential for the proper functioning of the alternator, as it supplies battery voltage and facilitates communication with the PCM through LIN. A loose connection can easily lead to unstable readings that the PCM interprets as communication errors, hence storing DTC P16E2. If any abnormalities are found during this inspection, they must be remedied by securing all connections and, if necessary, replacing damaged connectors. Ensuring the integrity of the alternator's connections is fundamental in eliminating potential causes of error P16E2. Next, focus on the LIN circuit for any open wires or shorted connections that may hinder communication. The local interconnect network, LIN, is critical for data exchange between the alternator and the PCM, and any disruption can lead to the DTC P16E2 being triggered. Use a multimeter to check for continuity and ensure there are no shorts to ground or breaks in the wiring. Proper identification of the wiring layout and careful inspection of connections is important to respond to this troubleshooting step effectively. If issues are discovered, appropriate repairs need to be made to restore proper circuit integrity and foster communication between components. The subsequent step requires inspecting the PCM and ensuring that all connectors are secure and intact. The PCM is often located in the engine bay or passenger compartment, and vigilance is necessary to examine its connector pins for any signs of damage or corrosion. Corrosion can impede electrical flow, disrupting communication with associated components, such as the alternator. Disconnect the PCM connector and visually inspect for any bent or broken pins, and apply cleaning methods as necessary to ensure proper contact. Should the examination show no faults, further testing may be necessary to confirm PCM functionality. After implementing the necessary repairs for DTC P16E2, it's essential to clear any stored DTCs from the PCM to ensure that the error is reset. Once cleared, conduct a test drive under regular operating conditions to verify that the communication errors have been resolved. Monitor vehicle performance and check for any warning lights reactivating. If the previously stored code does not return and the vehicle operates smoothly, it indicates successful repairs. This verification step is critical to confirm that all diagnostic processes were effectively executed and that the underlying issue was addressed. To prevent DTC P16E2 from reoccurring, implementing routine maintenance is vital. Regular inspections of the alternator, especially at the +B terminal, should be scheduled to ensure connections remain secure and free of corrosion. Additionally, monitoring battery connections is crucial because loose or damaged battery terminals can lead to similar communication errors. Keeping wiring harnesses in good condition, protected from wear and damage, will also fortify the reliability of the LIN communication. Proper preventive measures will help maintain the vehicle's electrical systems and ultimately enhance longevity and performance. In summary, DTC P16E2 points to a communication error between the PCM and alternator via the LIN. Identifying potential issues begins with verifying alternator connections inspecting wiring for shorts or openings, and ensuring that the PCM itself is functioning properly. Each step in the troubleshooting process builds on the last, revealing the components that may have malfunctioned and requiring attention. Employing preventive maintenance practices can significantly lessen the chances of this DTC reappearing. By understanding the implications of DTC P16E2 and implementing thorough inspection and repair protocols, we can enhance the overall reliability and performance of the Honda CR-V. Please like and subscribe to the channel. See you next time.